general formula of confidence limit that how we can write a general formula to get find the confidence limit of the mean of, let us start with infinite population. Infinite population. So this is the next concept. After this concept, we'll solve a problem on finding the confidence limit, confidence limit of the mean of the finite or finite populations. Then I'll give it a homework that will be at the end of lecture 3. Okay, lecture 3. Okay, so let us think in this case. We are none with factors that affect the rates of confidence level or confidence interval. So we say that let me teach you how the rate is formed. In most TIP classes, many teachers, they used to give you just this the formula of finding confidence limit. But you know that as an engineering or scientific student who is preparing himself or herself to solve a real world problems, you have to think, how do I derive this formula, right? You might not be asked to in exams to derive it, but you know it's better if you know where do you get it. Okay? It's a long kind of derivation. So you said so we'll be following some steps. So let's say that the first stage we are dealing with samples. So you say that let x1, x2, x3, then we continue to xn be the sample drawn, B is a sample of size, n, right? Of size n, drawn from the normal population. From the normal population, having a known variance or known standard deviation, having a known variance. At the first T, this is variance, right? Standard deviation square. Again, we say that suppose we want to use this sample, okay, to derive to obtain an 95 interval estimator for population mean. To obtain an 85% interval estimator for the population mean. Population mean, which is this. Okay, so we have some two parameters that population mean of 40 of that one. So we say that we start with the sample mean. So we say that let x bar to be the sample mean. The sample mean of point estimator. Sample mean of point estimator. Point estimator. Okay? And then let us say that we know that this mean or sampling distributions of means is equal to that. Okay. So let us think in terms of probability. So you have point estimator about the mean of population, which is x bar. So listen carefully. So this is point estimate about mean of the sample. This is mean of population or population mean. Listen carefully. Again, the second step, recall what I told you in the second chapter, which is called the sampling distribution. Recall the formula of what? The formula of sampling distributions of means for a finite, infinite population. So you say that this is equal to the known standard deviation of a square root of 40 sample size. Right? So suppose that this is the first equation. Again, so that the first step, okay? Or the second step, yes. Again, we say that you recall from the standardized from the formula, the standardized value is equal to statistical value xc minus mean of population of a standard deviation. So this is from chapter 1. So that is chapter 1. So again, if you want to know the standardized value of the sampling distributions of means, we say that in chapter 2, this we modify this formula that is equal to mean, and then this is mean minus mean of a standard deviations of means of sampling distributions of means. So this is equation 2. So look, there's a relation between equation 1 and equation 2, right? So we say that the standardized value now, ZC, this is equal to what? Is equal to, it means that this is the steady state now. So in steady state, we say that substitute what? Substitute equation 1 in equation 2. So we say that this is mean minus mean of population. Then you have what? You have standard deviation of what? Square root of sample size. So then this is equal to what? Square root of sample size. And then this is mean or point mean minus mean of population of a standard deviation. So this is standardized value, right? So standardized value, ZC, is equal to the square root of sample size times 40 times point mean minus mean of population mean of a standard deviation. So now the class is changing into the beauty of mathematics. So this is, suppose that this is equation 3. Okay? Again, we as statisticians, we have to think that another point that Z has standardized normal distributions, the value of Z that gives the probability of this one is that okay. So we go for the third step. First step. We say that we want to determine what, suppose you want to use that sample to obtain 95 interval estimator for the population mean. Use confidence interval at 95%. So we say that let us find the corresponding 20 this corresponding value don't see the necessity of having this corresponding value, so that we can just derive the find out. So we say that sketch the normal distribution. Sketch the normal distribution. So to sketch the normal distribution, suppose that this is our normal distribution, and then we have our normal curve like this. This is a symmetry, called the symmetry, and then suppose that we are dealing with 95%. Okay? So all of this region is 95%. So this is 2.5%, and this is 2.5%. Okay, so listen carefully. Suppose that here this is standardized value, negative on negative side, and here we have also the corresponding standardized value, which is positive. So to know the probability between these two values, we say that the statistical probability of negative ZC, this will be less than or equal to Z, less than or equal to positive ZC. So for this case, it will be just like is equal to 0.95 for this case. So 0.95. So that they are confidence level, that they measure that how confident we are. And then we say that, okay, fine. So if that's the case, we can have these values here. Okay? So we can have that value at that point, and then we want to determine the, for example, that we can say that this probability is equal to negative square root of population. So suppose that this is equation 4, right? Equation 4. But then let us substitute. So we go for the first step. We say that substitute. The formula you're deducing is just simple, it's not difficult. Substitute equation 3 in equation 4. How? So you say that probability of negative square root of sample size, and then we have point or mean minus mean over standard deviation, and this is less than or equal to less the value Z, and this is less than or equal to mean minus this one over standard deviation, just like. Okay, so let us continue. In the first step, we say that sketch the normal distribution. Let me just look a quick review. This is the normal distribution. This is a symmetry line. So probability of this side is, the total probability of this curve is 1, right? So this is 0.5, 0.5. So because we are confident enough about 95% at the confidence limit that we are going to derive is about 95%. So this is 2.5%, 2.5%, making a significance level of 5%. So then the probability between these two intervals, negative ZC, this is standardized value and this is standardized value. Okay, so probability of this one less than this one or within that interval is 0.9. So this is, suppose it's question 4. So because we have equation 4, the fifth step, we substitute equation 3 into equation 4. So because we have z here, so z is equal to point mean or mean, means that point estimate of the means minus population mean of our standard deviations, and then same sort of square root of population size. So this is the expression, and hence that I consider only the inner part. I just left the probability because we are looking for the formula of find the population mean, estimating the estimation or interval estimator of 40 of mean with known of populations with known variance. So then this is the considerations that I have negative z subscript of c less than square root of population size, point mean minus mean, population mean or standard deviations less than or equal to standard value zc. So we go for the sixth step. Don't get tired. This formula is simple. So the sixth step, we say that we make population mean the subject. So make population mean the subject. So to make the population mean the subject, first of all, we say that multiply by standard deviation to both sides. So you have negative ZC times standard deviation, right? And then we divide by population size to both, square root of population size to both sides. So this should be less than or equal to mean minus population mean. So this is sample mean, and then we multiply the standard deviation with standardized value, and then we divide with the square root of 40 sample size. Well, so if it's the case, we say that the next step, we say that because our objective is we make the population mean the subject, right, of the equation. So you say if that the case, you say that negative ZC times standard deviation of a square root of population size, we subtract the mean, the sample mean to both sides. This is less than negative mean, right? And then this is less than or equal to standard deviation times 40, so that is the value ZC of a square root of population size, hence minus 40 sample mean, right? So then we say that we divide by what? We divide by negative to both, to all the side, both side, left side and the what? Right side. So if we divide this negative, the symbols will change. The symbols will change, right? So the symbols will change. Because the symbols will change, we say that we have the minimum part or the maximum part and the minimum part. So we say that the minimum part we say that mean, because we say that the minimum part will be what? We say that positive mean will be greater than or equal to what? Or equal to point mean minus or sample mean minus what? Standard deviation z subscript of c over square root of 40 of sample size. And hence, if we consider the maximum part, okay, the minimum part, okay, the maximum part, we say that mean, this is equal to what? Sample mean plus what? Plus ZD, and then ZC over the square root of 40 of M. So remember that you have greater than or equal in probability, that we can say that we need a greater than symbol, and then we can have a formula like that. So from this concept now, we say that if that the case, we say that the sample mean minus standard deviations of population times standardized value at the confidence level, at the means of CC represent confidence level, at a particular confidence level over this one. This will be less than or equal to population mean, and this will be less than or equal to the summations of this standard value, standard deviations of times what is standardized value at the significance level over this population mean. See? So this is a general formula, but in most cases we don't use this formula in this form. we just say that we use it in this format, that confidence, say confidence limit. So confidence limit at a particular confidence level is we determine by using what? Population sample mean plus or minus so that is the value times what? Standard deviation over square root of 40 of population size. So this is a very important formula in this topic and even in the next topic, but especially in this topic. And we'll be just having that instead of having sample means, you can have proportions, you can have maybe summing or sum of proportions, sum of the means or difference of means. So simply is the general formula. But also saying that you can say that the confidence limited generally, so this the general formula, will be equal to the sample mean plus or minus what? Standardized value, let's see, times what is some standard deviations or sampling distributions of 40 of means. So this is the general formula for infinite population. For the finite population, the interval estimate of mean with known variance, we say that for the finite, say finite, for the finite population. So for the finite population, we say that for the finite population, we say that the sampling distribution, the standard deviation sampling distributions of mean, this is given as what? This is given as population size minus sample size. This is sample size, excuse me, this is sample size. N stands for sample size, not population size. So you say that this one is given as standard deviation over square root of sample size, and then here we have again what? We have a square root. Yeah, we have a general square root of population size. Population size is notated by this minus 1 over the population size minus sample size. So that's the form. Okay? No, this is vice versa. So here we have, in the numerator we have sample size, and here we have minus 1. So it means that the confidence limit for finite, in case you'll be given finite population, okay, for finite population is given as what? For finite population, we say that this is given as standard deviation of a square root of population of sample size. Is sample mean plus or minus standard deviation times standardized value over square root of sample size, and then we say that here we have a square root of what? Population size minus sample size over population size minus 1. So again, this is our general form. Right? That is simple like that. Do you enjoy it? In case you have any question or you didn't understand any point of this derivation, please ask me in the comment sections and I will try my level best to help you. Is engineering mathematics beautiful for you? Yeah, to me it's beautiful and I like it so much. So those are the general formulas that of confidence limiting for a population mean with known variance. Well, so if that's the case now, we can go to the examples. This will be example 6. If you join me right now, you are welcome into these fantastic sessions of statistics. So it's a kind of the long question, but yeah. I'll write this question and then I'll leave the homework for you. Also this one, and then I'll leave homework for you. So let me start on this side because it's a long question. But these are the information, for example, 6 and 7. Suppose that you have to experience long questions of 40, long and short questions of statistics and probability. Suppose that if a signal having intensity mu originates at location A, then the intensity recorded at location B is normally distributed. It's normally distributed with mean. And the standard deviation. Standard deviation of the ray. That is due to the noise. The intensity recorded differ differs from the actual intensity of the signal by an amount that is normal with mean. Mean of 0 and standard deviation 3. And standard deviation of 3. Reduce error. Same signal. Same signal is independently recorded 10 times if the successive recorded values are values are 20, 17, 21, 18, 19, 22, 20, 21, 16, 19. It's 30, 25, confidence interval, for mean, interval for mean, the actual intensity. Actuality intensity. So that the question which has been given at this level. Suppose that if a signal having intensity mu originate at a location A, transmitted to location B, then intensity recorded at location B is normally distributed. So transmitted from location A to location B. And then Swiss mean and standard deviations of 3. That is due to the noise. The intensity recorded differs from the actual intensity of the signal by an amount that is normally with mean of 0 and standard deviations of 3. So that is due to the noise. So there's an issue of noise. The intensity recorded differs from the actual intensity of the signal by an amount that the normal is mean of 0 and standard deviations of 3. To reduce error of noise, the same signal is independently recorded in 10 times. So it's being recorded 10 times, not 1 times. 10 times to reduce errors. If the successive recorded values are 20, 17, 21, 18, 19, 22, 20, 21, 16, and 19. Construct a 95% confidence interval for mean of the actual intensity. Solution. It's not a difficult question. Very simple question. Solution. So first of all, you'll be given start. You'll be given. Let us start with the first stage data given. You'll be given standard deviation. So standard deviation, and in entire module, standard deviations of population. Standard deviation of population, we are using this symbol. So this is equal to 3, right? And then so be given the sample size. The sample size, the experiment has been done or repeated, the sample size has been repeated 10 times. So it's equal to 10. And then we don't have statistical mean at 10 times, and then we have the statistical values. So what's required? So we say that first of all, mean, sample mean, which is point estimator, sample mean, and for this case, this one, this is required, right? Required. So how do we find it? But the issue is the confidence limit. We need the confidence limit. That's the range of course 30 and 95% confidence interval for mean. Confidence limit for mean. This also is required. Right? So we go for the second step. The second step from the point estimate, we call the formula. So from lecture 2, I took the point estimate. The formula to find the point estimate about mean, this is equal to summations of xi from I is equal to 1 to n over n. Okay, so refer what I told you in previous session and previous lectures. Do you enjoy probability and statistics? Please let me know in the comment section. Do you understand what am I teaching you? Please let me know in the comment section. Okay. So you say that the point mean is equal to the sum of this, which is 20 plus 17 plus 21 plus 18 plus 19 plus 22 plus 20 plus 21 plus 16 plus 19. This one we divide with what time? So the pointing estimate of mean. Use your scientific calculator, find the sum of numerators, then divide with denominator. But use your scientific calculator, the point estimate of what mean, it will be 19.3. 19.3, right? Yeah. That is the second step. Let us go to the third step. The third step, now we know the point estimate. We have to check, are we given the confidence level? Yeah, so you're being given also confidence level. I forgot here to mention the confidence level. So confidence level is 95%. So, as I told you, there's no need for you to claim the different confidence level with their corresponding standardized value. I gave you a promise that I would use the simplest way to determine. So you say that, but in case you remember it, just you plug it. There's no need for you to worry. So we say that identify the standardized value corresponds to what? Correspond to 95%. How? So we say that probability of a certain standardized value at C less than daily, so it means that from the normal distribution curve, from this normal distribution curve, this is the bell-shaped curve. So you find that suppose this is negative ZC and this is positive ZC. Right? So this is total probability of 95, level of confidence level. So we say from this table, probability of negative ZC less than or equal to Z less than or equal to positive ZC, this is equal to 0.95. So you want to use the normal distribution standardized table. So in order to find itself, it's just giving us value from 0 to positive ZC, right? So in order to identify the corresponding Z, so we say that we have to identify, or we have to find probability of what? 0 less than or equal to Z less than or equal to ZC. This will be equal to what? 0.95 over 2. So the answer is 0.4 and then CF7, 5. So any confidence level you can use. If it is 50, you just place 50. then you find to find probability from 0 to ZC corresponding to 50, it will be 0.5 over 2, which is 0.25. If it is 60, similarly, just replace there. So to find the corresponding probability or the probability between 0 and ZC for 60%, it will be 0.6 over 2, which is 0.3, right? So we know now the probability corresponding, the probability between 0 and ZC. So we have a standardized normal curve. We can now identify the value of 40 of C. That will be the force state of ZC, excuse me, not C. So the force state, we say that we use the standardized Z distribution, use the distribution table, okay, table to find what? To find ZC. Corresponds to what? Corresponds to 0.4750, right? So take your normal distribution table and I will show you how you can use it. You have to remember what I taught you in previous chapters on how you can use these normal distribution tables. So then we say that the value of ZC now should be, so this is our table for area under the standard normal curves from 0 to ZD to Z. So this is our normal distribution curve, right? Let me just bring it near to the lens. Okay, so it means that what do we need? The probability that we are dealing with is this probability less than Z less than or ZC. This is 0.4750. So you have to deal with probability of, so find the probability of 0.4. So 0.4, we have several values of 0.4. But let us go 0.47, so add the 1 decimal place. So you just visit it, so 47 here, then go to 0.4750, yes, this one. So 0.4570. The corresponding ZC is what? 1.9, and then the second decimal place is 6. So the corresponding ZC is 1.96. Well, so if you have that one, then we got the fifth state. We say that let us find out the confidence limit. So from the formula, we say that confidence limit, this is given as sample mean plus or minus, that is the value that we found there, standard deviation, which is 3, over square root of 40 sample size. So the confidence limit for that case is 19.3 plus or minus, so Z value is 1.96, standard deviation is 3, and then over square root of sample size, which is 10. So use your scientific calculator to do that computation, and then you'll find that the confidence limit now will be lying between those values. So we say that the confidence limit constructed of the confidence limit is given as what? 19.3 plus or minus. If you do this computation, you'll find that it is 1.859. So let's say it is 19.3 plus or minus 1.859. Yes, 859. 1.859. That is. Or you can add and subtract, or you say that the population mean, or you can assay it with define confidence that the population mean lies between 17 0.4. It means that also we can take, let's say, 19.3 minus 1.859, and also on another side you can take 19.3 plus 1.859, right? So we say that we can assert, so in statistics we say that we can assert with confidence, level of 95%, that they mean that the actual intensity of the signal, that the actual intensity of the signal lies between 17.44 and also you have what, 1.16. So also we can conclude our solution by writing the response in this form. Is statistics interesting? Yeah, it's very interesting. So now it's the time for the homework. Let me give you the homework, and then to be the end of this session, you have to join me in the next session of probability and statistics. This is about the reference syllabus of the Islam Institute of Technology, but also I teach another modules or another course we call it probability statistics for non-measures. It's a reference for all the institutions, all the universities. So homework, and I will teach you homework 3. And this is example 7. Try this homework with yourself before you watch lecture 4. Refer data of example 6 above. Okay, above, determine. So the homework, refer data of example 6 above. Determine from an R a 90% confidence interval estimates of mean for the data of example 6, and also B, a 99 confidence interval, percentage confidence interval estimate of mean of population mean. So if you do that, then you are in a good position on understand the interval estimate about mean with non-population variance. That's the end of lecture 3 or session 3. I thank God who have been with me during the preparations of this lecture and even during the times that I'm teaching you. Thank you. I thank God also for you, and I thank you yourself for taking your time and being with me from the beginning to the end. Don't hesitate yourself to ask many questions as well as you can in the comment sections, and I'll try my level best to answer. And make sure that the procedures are the few steps that I ask you to do in order for you to stay connected with our online undergraduate Polytechnic Institute of Tanzania, Olenjolaim in square brackets. So thank you very much. May God bless you. Meet you in the fourth lecture, or the lecture 4 of probability and statistics. Remember also that I'm teaching another modules in the same YouTube channel that called Statistics for the Non-Measures, and that's for all the universities of United Republic of Tanzania that who are for the courses, for the students who are pursuing engineering or any engineering course and the scientific courses, right? And I teach you. And this is specifically for all the institutions and colleges which are laid under the NACTI, right? So, but the materials might be used worldwide. So thank you very much. May God bless you. Stay tuned. See you in the next lecture.